This is a short video on how to analyze spectra in the new Specky. So I'm going to show you here how to analyze this suite of spectra from Rachel Kozlowski, who shared this so that we can add it to the reference library. I haven't gotten it added yet, so now it's going to be a good test case for how you can do batch analysis in the new Specky software. So first, what you want to do is you want to put all of your spectra that you want to analyze into a zip folder. They should all be some file that you could normally upload one at a time into Specky. Then you'll take that zip folder and upload it. You can choose to share your data or not share your data by selecting that. But we're just going to go ahead and share. And that data uploaded pretty quick. We just uploaded 50 spectra, different spectra of PEK polymer. You can select here on the heat map to see what that spectra looks like. This heat map is being colored based on a threshold that we set for the signal to noise ratio. So you can see that setting here, and you can play around with that. 4 is probably about the lowest you want for a typical signal to noise ratio. And what this is telling us is that our spectra really don't have very good signal to noise right off the bat. So what we can do is we can pre-process them. So we just select that one button, and it pre-processes the spectra using the default setting, which is the absolute first derivative. We found this to be really good at increasing signal to noise and increasing your match accuracy, and it's a really fast algorithm too, so that's really nice. So once you have your spectra and they're mostly above our signal to noise ratio, there's still one that's kind of low here, but most of them are above our signal to noise ratio. Threshold, we can click identification, and it will start identifying all 50 of those spectra that we uploaded in the zip folder. You can see it takes a minute because we've updated the reference library. It has several tens of thousands of spectra in it now, so it's going to take a little bit longer to be able to identify things, but we think with this new batch algorithm, that's really gonna compensate for that decrease in speed for individual spectra, because we're really wanting people these days to start to think about how to batch analyze their spectra instead of going in one at a time and analyzing every single spectrum independently. So this image has now changed so that it's now showing us not just the good signal, but also the good correlation. So there's also a correlation threshold that you can set here. We set it at 0.7. If you set it at 0.6, some of those squares will become colored. 0.7 is a pretty good one to set it at in general. And so what we would do with this now is we could download this data, say these spectra here that are of these pixels that we have good signal to noise of, good correlation thresholds. We would say we know what this is. This is a PEK. The other ones, maybe we'll download that data and try to investigate those further using manual procedures and stuff like that. So this just gives you an idea of some of the ways that you can use the new Specky batch algorithm. I'm going to go into a much more detailed explanation of all the new functionality in Specky that you can use. The last thing I wanted to show you is how to download your top matches. So this download button will download your top matches. It's going to give you a CSV file that has every single one of your spectra here, and the top library ID that's being returned, a bunch of metadata. I won't go into it. It's literally over 100 different pieces of metadata that we've stitched together into it. So I hope you like it.